Okay, so we're going to be practicing how to find the inverse today, but of what they refer to as general forms of exponential and logarithmic. So the exponential is a times b to the x plus h plus k, and the logarithmic a times log base b of x plus h plus k. Basically, we're just expanding these functions with some transformations, specifically translations. All right, now it's the same set of rules that we've looked at prior when it comes to an inverse. Number one, switch the positions of x and y in the equation. Number two, use the inverse operations to solve for y. Once you've got y, number three, write the final inverse function using the correct notation. So it's referring to that -1 notation that we have. Okay, so let's just get right to it. I want to find the inverse of f of x equals 3 times 2 to the x plus 4 minus 15. So I'm going to start by replacing f of x with y. Okay. Now the first step is to always go ahead and switch the positions of x and y. So I'm going to say x equals, then we have 3 times 2 to the y plus 4, and then minus 15. Okay. Now remember, my goal here is to go ahead and isolate the y. So what do you think I'm going to do first? Okay, we're going to add the 15. What I want to work towards right now is getting the 2 to the y plus 4 completely isolated. So if I add the 15, x plus 15 is equal to 3 times 2 to the y plus 4. Now, what is the inverse of an exponential? It's a logarithm, right? So at some point, I'm going to have to take the exponential and convert it to a log. Am I ready to do that? Now, the exponential isn't isolated yet. What do I still got to get rid of? Got to get rid of the 3. There we go. So I'm going to go ahead and divide through by 3. Now I'm going to break it apart on the left side. If you want to leave it as x over 3, that's fine. I'm going to go ahead and say 1/3 x plus 15 divided by 3 would give me 5 equals 2 to the y plus 4. Now that that exponential is completely isolated, this is when I'm going to change it to a logarithm. Okay, who can tell me what the log equivalence is? Remember, every exponential in log always has 3 parts. You've got the base, the power, and the argument. So what base do we have here? We got log base 2 of, what should go in the parentheses? What's that? 0? Okay, y plus 4? Not quite. What's the only thing left? The 1/3 x plus 5. Now I'm going to go ahead and stop there for just a minute. Remember, what is a logarithm in one word? What describes it? It's an exponent. It's a power. That is all a logarithm is. So any log statement that you write, it has to equal whatever power you're working with. So in this case, it has to equal y plus 4. So that means that 1/3 x plus 5, it would have had to have been our argument. It's going inside the log. Now I've got one step left. Let's go ahead and subtract that 4. So log base 2 of 1/3 x plus 5 minus 4 is equal to y. And this is what step number 3 in that box above was talking about. Once you get the y by itself, I'm going to go ahead and remove it. And I'm going to replace it with the notation. We had f of x, so I'm going to say f inverse. Here we go. There's my inverse. So we're just taking some properties we know about logarithms and basically algebra, and we're just finding the inverse. Anybody have any questions? Not terrible, right? Okay. All right, well, let's try number 2. Now this time I want to take a log and I want to find its inverse, the exponential. All right, so this starts y equals. So I'm going to switch x and y. So x equals -3 log base 5 of y minus 4 plus 6. Okay, so I switched the x and the y. Okay, walk me through this. Addie, what's first? Okay, we're going to subtract the 6. So x minus 6 equals negative 3 log base 5. Y minus 4. Perfect. Okay. Reed, am I ready to convert yet? Or not? Oh, okay, let's get rid of that negative 3 here. So negative 3, negative 3. Okay, I'm going to do just like I did in the previous problem. So this would be a negative 1/3 x. Negative 6 divided by negative 3 is a plus 2 equals log base 5 of y minus 4. Okay. Now that the log is isolated, now we're going to do what? Remember, what's the inverse of a log? An exponential. So now we're ready to convert it. Okay. So what's my base? Base 5. What would the power be on 5? And remember what I said a second ago. What is a log? Power. A log is a power. So any log statement that you ever write, whatever it equals, that's your power. Okay. So I have to raise this to the negative 1/3 x plus 2. Well, what am I going to set that equal to? Y minus 4. Here we go. It's the only thing left. And then all we got to do is add the 4 over. So 5 to the negative 1/3 x plus 2 plus 4 is equal to, now, instead of writing y and then erasing it, I'm just going to go ahead and put in the notation. So g inverse of x. There we go. Just like that. Easy, right? Does anybody have any questions? Dokey. We got one question left. Okay. Go ahead and leave that up there for just a minute so you can still copy that if needed. So it says let h equal 3 to the x plus 1 minus 2, and let k be h inverse. So k is the inverse of h. For what value or values of x does k of x equal 1? Okay, now there's two ways you can actually approach this problem. Okay. Let me go ahead and get this out of the way. So I could go ahead, take this exponential right here. I could find the inverse of it. I could go ahead and say x equals 3 to the y plus 1 minus 2. Once I find the inverse, then I can go ahead and set it equal to 1 and go ahead and solve for x. Okay, it's not a very hard method to do it. It'll be probably about as long as the previous two examples, so it's not terrible, but there is a way to pretty much get the answer within seconds and far less work. Okay, so I will do whatever you folks like me to do. You want me to actually find the inverse and then solve the equation, or do you want me to show you the shortcut? Show you the shortcut? Okay, let's do it this way. So k is the inverse, right? So the point that's going to be on this function k, we're trying to find the value of x when y is 1. Would everybody agree? Okay. Well, k is the inverse of h. Okay. Remember, what is the core idea when it comes to inverses? What do I do with the x's and the y's? We flip them, right? We switch them. So this y value that's 1, it would become an x value that's 1. This unknown x right here would become an unknown y. What does anybody think they know where I'm going with this? Yeah, if we know what the value of x is, all I got to do is plug it in here. So 3 to the x plus 1 becomes the 1 plus 1. Minus 2, 3 squared minus 2, 9 minus 2. Far less work if we use the idea of the inverse. Now, if you're wanting to, I did go ahead and find this. Oh, let's see what it was. If you did want to go ahead and find the inverse, function k is going to look like this. And you can use this for practice. But log base 3 of x plus 2 and then minus 1. So if we went with the original idea of finding the inverse of that exponential, this is what you should be ending up with. And then in order to solve this part right here, well, you would just take the inverse, set it equal to 1, and solve that for x. Okay. But it's going to go ahead and give you the same answer. All right. Questions? How we doing? Okay. Good. All right. Well, that's all I got for today. Okay.